Hello. Today we're going to be continuing our exploration into probability through the lens of Google Sheets. We're going to start today's lesson by exploring two new formulas. You'll see in a second that they're very similar. The first one is called the RAND formula. This one outputs a random number, hence the name RAND, between 0 and 1. Let's give that a shot. So let's say that we want to get a number between 0 and 1. We're going to type in equals to make it a function, and then the RAND formula, R-A-N-D, and then open and close parentheses. And you can see here that it outputs a random number. It outputs, in this case, 0.4858, etc. So this here is my randomly generated number between 0 and 1. That's great, but sometimes we want to find a random number between two specified numbers. So let's say that I'm trying to find a number between 1 and 100. And I want it to be random. What I will do is use the RAND between formula. So let's try that out. I put equals to make it a function, RAND between, and then I want to put the low bound, like you can see here, and the high bound. In this case, I want to be between 1 and 100. So I have the low bound be 1, comma, you can see it switches to the high bound here. I'll choose 100. So once again, I click enter. It'll give me a randomly generated number between 1 and 100. In this case, 11. Okay, so this is our quick introduction to these new formulas. But why do we care about that? Well, let's go off of one example. We're going to do an example together, simulating rolls on a dice using a random number generator. So here's our scenario. I'll make this a little bit bigger so we can all see it clearly. We are playing this game over here called Settlers of Catan. And we're going to win the game unless we roll a 7. You roll the die, and unfortunately, you roll a 7. You lose. You're frustrated, and you decide to figure out how likely that was to occur. What you're going to do is you're going to model the scenario with many possible sums of the two dice, and you're going to see if you can use that to determine the likelihood of having rolled a 7. Okay, so our target number is a 7. We are going to simulate two dice. We're going to sum them together, and we're going to see what happens for 5 simulations, for 50 simulations, and for 100 simulations. So let's give this a shot. So what do we know about dice? I'll invite you to pause the video here and see if you can think of what you can put in to make this cell represent all the possible numbers randomly on the die. Okay, so one possible way of doing this is we know that we want to use our RAND between function, and we want the numbers that can appear in a dice, 1, 2, 3, 4, 5, and 6. So we want it to be randomly between, RAND between, open parentheses, the low bound is 1, the high bound is 6. So that gives me a random integer between 1 and 6. You can see in this case, it gave me a 5. Well, my second die, it's also going to be the exact same thing. And I have a random integer between 1 and 6. So I'm just going to highlight this, Control-C, and paste it over here. You can see here that Google Sheets automatically updates the randomness every time you click a new cell, or you enter in a value of a new cell. So now I have my random dies on 2 and on 1. Now, obviously, I want to sum them together. I want to figure out what I roll when I actually roll the two dice. So I can sum them together. I can either, again, manually add them, 2 plus 1. So I could type in 3, but that would take a long time. So what I'd rather do is introduce the sum formula. So I can equals sum, and then I highlight the two cells. So now it sums everything in these two cells. In other words, it sums what's on this row. So I'm typing equals sum, highlighting the cells, close parentheses, enter. And you can see here that in the first die, I rolled a 5, second die, I rolled a 3. Sum them together, I get an 8. Okay? This is my first set of randomly generated dice and my first set of randomly generated sums. So what I'm going to try doing is simulate this more and more times. I've now simulated it once. I'm going to show you guys a trick. If I highlight everything that I want to copy and paste, it's going to automatically copy and paste the formula. If I hover over the bottom right corner and drag down. Let's give that a shot. I highlight everything here, go over the bottom right corner, 1, 2, 3, 4, 5 times. Okay, so here are my dice. I got a 6 and a 4, summing to 10, 5 and a 2, summing to 7, 6 and a 3, adding to 9, 3 and 3, adding to 6, 5 and 4, adding to 9. Okay, so let's see what's happening here. I want to find the probability of getting the target number, which again was a 7. You'll see as I start to input in numbers, these are going to change. That's okay. They're still going to be random. So the number of times that I rolled the target number. Well, that's like what we did yesterday. That involves the count ifs statement. So what we're going to do is we want to be focusing on this column here. And we can do equals count ifs. I want the range of numbers. In this case, it's these 5. But just to make my formula work for all of them, all the way up to 100, like I see over here, to make it work for all of them, I'll just highlight the whole row, the whole column, 100 down. And you can see here that it's already nice and color coordinated. C31 to C130 gives me all of those values. I'm counting all of them. I'll go back up here. I've counted all of them now. And now I want to figure out what is my criteria. So that's the criteria there. Sorry, that's the range of values. And I want it to be if it equals my target number, which is 7. So I'm going to literally type in inside of the quotation marks, like I can see here, equals 7. And the quotation marks, and now it counts it. So you can see here, it did work. I have one sum here that's 7, and it gave me a value of 1. Now, the other thing I want to do is, what is the number of tries? Well, again, that involves the formula that we used yesterday. We have to count the number of things. So I've done 1 trial, 2 trials, 3 trials, 4 trials, 5 trials. I should expect this to be 5. If I can do equals count. And then once again, it'll be these 5. And again, I'll just make the formula work. These are all blank cells, so they won't affect the data set. I'll just scroll all the way down so I can continue using the same formula. So the count formula, I'm counting all the written in cells between C31 and C130. Now I count that, I should expect that to be 5. I can see here if I added another number, then now it'd be 6. So you can see what's happening there. And then finally, the probability of getting the target number. Well, that's equal to the number of times that you rolled the target number, in this case A26, divided by the number of tries, A27. So I type in equals A26 divided by A27. That gives me the probability. My experimental, because I'm literally experimenting randomly, probability. So you can see in this case, it's 0%. I've rolled 0 7s. So I'll make sure that I write that down. I got 0. Now, is it actually a 0% chance? Of course not. However, we're just recording what's happening with our random sample. So that's what happens if I roll the die 5 times. Let's say I wanted to roll it 50 times. Well, I can once again use the same trick. I highlight my cells here. I already have the same formula that ran between 1 and 6. the rand between 1 and 6, and the sum. I'm going to highlight those and go down 50 tries. So 31, I should go down to 80. So I go down to row 80, and now you can see I have much more data. So what's happening now? Now I have an 8 in 15 chance. So I got a 16% probability. The cool thing about Google Sheets is that it keeps on updating this. So now I have a 16% chance. So we're going to record that, 0.16. And finally, what if we roll 100 times? If we roll 100 times, that scrolls all the way down to the end of the orange at 130. I can see all these 7s appearing. And I can see that I have a 15% chance, 0.15. So these are random experiments. This is not the actual number, and you can see that it keeps on changing. Now it's 17%. Every time I type in a new thing, it updates the randomness. But what's going to happen is the more times I simulate this, if this was going to be 1,000 or 10,000, which is really easy to do on Sheets, I just continue dragging and dragging and dragging, then I'm going to get closer and closer to the theoretical probability. So it's important to be able to calculate out the experimental probability versus the theoretical. And you can see here what's happening. It looks like it's about 0.15, 0.16, 0.17, and indeed that actually is what it is. The theoretical probability is actually 1/6 or 16.7. So you can see here that my experimental probability was indeed very close. So that's the goal of today. Practice using your random number generator, practice using your count if statement, practice using your count statement. And now you'll be tasked with doing the same sort of problem, except now you're looking at what are the chances of rolling a 6. They're not going to be 16%, they should be something else. Let's see if you're able to figure it out. Good luck, and see you tomorrow.